In this class, we will derive the sigma square. In the last class, we defined variance of beta 2 cap equal to sigma square by sigma xi square. In this class, we are going to derive the estimates of this sigma square. That is sigma cap square. That is least square estimate of sigma square. We can derive the sigma cap square equal to sigma ui cap square divided by n minus 2, or sigma cap square equal to summation of sigma cap square equal to summation of ui cap square divided by n minus 2. This we want to prove, and this is the least square estimate of sigma square. This is the least square estimate of sigma square. How we can derive this least square estimate of sigma square? We know that sigma ui cap square equal to sigma of yi minus beta 1 cap minus beta 2 cap xi. This is the least square criteria that we have already discussed. And yi equal to beta 1 plus beta 2 xi plus ui. This is the another equation we need. And the and its mean value is given as y bar equal to beta 1 plus beta 2 x bar plus u bar. That is the equation number 2. And 1 minus 2 will give the equation as, that is, subtract this equation from this one. That is yi minus y bar equal to beta 1 minus beta 1 plus beta 2 xi minus beta 2 x bar plus ui minus u bar. Then yi minus y bar is defined as small yi. Beta 1 minus beta 1 is 0. Then beta 2 xi minus beta 2 x bar. Beta 2 can be common. Then beta 2 xi minus x bar. That is, xi minus x bar can be written as small xi. Beta 2 xi. Then the remaining portion is ui minus u bar. Let it be like this. That is, yi minus y bar, small yi, beta 1 minus beta 1, 0. It is not given here. 0. Beta 2 xi minus beta 2 x bar. Beta 2 common. Factor out beta 2. Then x minus x bar. Then beta 2 into x minus x bar can be written as beta 2 into small xi plus ui minus u bar. And next important definition is that in the deviation form, we know that yi equal to beta 2 cap xi plus ui cap. This already we defined. It is in the deviation form. That is, yi equal to beta cap plus xi plus ui cap. Here ui cap equal to yi minus beta 2 cap xi. This definition is used in the fourth equation, ui cap equal to yi minus beta 2 cap xi. So therefore, the equations, this is the least square criterion. Then second one, the linear equation. Then its mean value is given. Then subtract this from this one, its value is given. Then the fourth equation, from the deviation form, we defined ui cap equal to yi minus beta 2 cap xi. Now substitute this 3 into 4. That is, substitute yi using this equation. Then we can write this equation number 4 as ui cap equal to this one, yi equal to beta 2 xi plus ui minus u bar. Then remaining is beta 2 cap xi. That is what we have done. First we have this linear equation. Then its main value is given. Then subtract this from this one, its value is given. From the deviation form we defined ui cap and replace this yi using this equation 3. That will give ui cap equal to beta 2 xi plus ui minus u bar minus beta 2 xi. Then here we are going to do some mathematical equations and techniques. Here collect the whole term. Here beta 2 cap and beta 2 and beta 2 cap, these two terms can bring together, then it will give beta 2 xi minus beta 2 cap xi plus ui minus u bar. These two terms can, this beta 2 cap xi minus beta 2 cap xi can be taken as a and ui minus u bar equal to b. Then this can be written as a plus b form. Then square this, then we will get a plus b the whole square. Then its expanded form is a square plus b square minus 2ab. This beta 2 here, bring these two terms together, beta 2 xi minus beta 2 xi, then ui minus u bar, take this square and sum on both sides. It is given here, that is beta 2 cap minus beta 2 the whole square of sigma xi square plus ui sigma ui minus u bar the whole square minus 2 xi, that minus 2 beta 2 cap minus beta into sigma of xi into ui minus u bar. This is the fourth equation. Now we will get this equation. Now next we are going to bring these two terms together, and we will in the next we'll square these terms and take the sum on both sides. Then we will get beta 2 cap minus beta 2 the whole square into sigma xi square plus sigma ui minus u bar the whole square minus 2 beta 2 cap minus beta into sigma ui minus u bar. Then take the expected value of the whole term, that is expected value of ui cap square equal to sigma xi square, then expected value of beta 2 cap minus beta the whole square plus expected value of sigma ui minus u bar the whole square, then the expected value of all these terms. Then we will get sigma xi square. This expected value of beta 2 cap minus beta 2 the whole square is nothing but the variance of beta 2 cap. Here this expected value of ui minus u bar the whole square is the second term. Now we want to prove this, we want to get the solution to this one. Then the remaining portion is expected value of beta 2 minus beta 2 into sigma of xi into ui minus u bar. Then this will give minus 2 into sigma beta 2 cap minus beta 2 can be written as ki ui xi into ui. Xi ui minus u bar is ui. It is given here. We will derive the value for this one, that is expected value of sigma ui minus u bar the whole square. That is expected value of ui minus u bar the whole square equal to, this can be written as expected value of sigma ui square minus this u bar n, when if it that is the expected value of sigma ui minus u bar the whole square. Then now distribute sigma to this equation, then that it will give expected value of sigma ui the whole square, square is also the then sigma u bar if we distribute sigma to here, we know that it is a constant and we can write this as n into u bar the whole square. That is expected value of ui sigma ui square minus this n bar u bar equal to sigma u by n. That is, we know that x bar equal to sigma x by n, like that u bar equal to sigma ui by n. We know that x bar equal to sigma xi by n, like that u bar equal to sigma ui by n. This the expansion for the u bar can be written like this, that is expected value of ui square minus n into, replace this u bar by sigma ui by n the whole square. That is the expected value of sigma ui square minus into 1 by n, we can factor out this 1 by n into sigma ui the whole square. That is, then multiply the whole equation by n, it will give n sigma ui cap square is sigma square, that we already know. Then it will equal to n sigma square minus n into 1 by n into sigma ui square equal to, here also sigma ui square equal to sigma square, that is n by n sigma square equal to, here n by n is 1, this can be written as n minus 1 into sigma square. This is the expected value of sigma ui minus u bar whole square, it can be written as n minus 1 sigma the whole square. Here how we derive this x minus 1 n my expected value of ui minus u bar whole square equal to n minus 1 sigma square. Then first distribute the summation, then replace this u bar by sigma ui by n, then take the common form here, then distribute, take the LCM or multiply the whole term by n. Then the first equation is sigma xi square into expected value of beta 2 cap minus beta 2 the whole square. This is variance of beta 2 cap, and the variance of beta 2 cap is defined as sigma square by sigma xi square. Then this sigma xi square will cancel out, the remaining portion is sigma square, the n minus 1 into sigma square. This is the value for expected value of ui minus u bar, and 2 expected value of sigma ki xi into ui the whole square. This whole term can be written as 2 into sigma square. Then if we replace this bracket, we will get sigma square plus n sigma square minus sigma square minus 2 sigma square. Then we will get this sigma square and minus sigma square will cancel out. The remaining portion is n minus 2 sigma square. Let us remove this equation, this bracket. We will get n sigma square minus sigma square minus 2 sigma square. Then this sigma square and this sigma square will cancel out, and the remaining portion is n sigma square minus 2 sigma square. Then it is equal to n minus 2 sigma square. That is the expected value of ui cap square equal to n minus 2 sigma square. Then the estimates of this equation, sigma square equal to, that is sigma cap square. The estimate of sigma square is sigma cap square equal to, divide this equation by n minus 2, that is expected value ui cap square by n minus, that is sigma square equal to sigma square, from this sigma square equal to expected value of ui cap square divided by n minus 2, and the estimates of sigma square, that is sigma cap square equal to, take the expected value sigma ui cap square divided by n. Then expected value of sigma cap square equal to 1 by n minus 2 into expected value of ui square, that is that will be equal to the sigma square, that is sigma cap square is an unbiased estimates of sigma square.